All right, folks, let's start. Hello, everyone. This is Dr. Yuzo, ECE 341 Power System class. Today is our 16th lecture. Okay? And from the Gantt chart here, well, can you guys hear me and also being able to see the Gantt chart? All right, thank you, Gavin. Yep. All right, we can go ahead. All right, thank you. So we're at it's October 26th, Monday. First lecture for new module 5. And well, midterm example 2 is upon us, right? Right after this module. So you want to be ready for this, all right? So the exam 2 will be in 2 weeks, okay, from today. All right, let's move on. Module 5 is about optimal dispatch of generation. Optimal dispatch of generation. So what this module is about. What this module is about. It's very simple. Yeah. You study minimum cost of power generation. Or say find the minimum cost of power generation. Say the customer requires 500 kilowatt. You have to provide this amount. Obviously, there's no negotiation on like how much less we can provide. There's no negotiation like this. So you have to provide this amount. And meantime, think about a way how to minimize the cost. Right? This is the what this module is about. Okay. And it's actually pretty much a mathematical problem. It's a mathematical problem. And this is modeled as I said, a mathematical problem. What is it? Just find minimum value of a objective function subject to constraints, or say constraint functions. This is the mathematical model, or say how we solve this problem. Right? So first of all, we are seeing an objective function. Now, who is the objective function? According to the description we had just had, objective function is nothing but what? Cost function. Doesn't make sense. How much you need to spend to have this amount of required power happen? Okay. The objective function. How to minimize it? Find the minimum value of it. The meantime, subject to constraint function. Okay. We have other functions, constraints function. The objective function must subject to it or them. Okay. And of course, both objective function and constraint functions have multiple variables like this. like what? Example, our objective function is defined as f of multiple variable, right? Multiple variable. Let's say we have up to n variable. Sorry, obviously cannot be equals to anything, right? You're looking for the minimum value of this function, so this function cannot be something equals to something, right? That doesn't make any sense. It's objective function. Okay. Subject to constraint functions. What are they? They look like this, right? And the constraint function might be plural, okay? Might be more than one. So we give a subscript of 1. And also, constraint function obviously has to be equal or maybe less or greater than 0, right? Does it make some sense? The constraint function is something objectively existing, right? So it may be a function equals to 0, greater than 0, or less than 0. It's not something uncertain. It's something quite certain. Of course, by writing in this way, it might be equality constraints or inequality, right? Of course, it's possibly to be inequality. And as said, we have might more than one. Up to say k. So all of these constraint functions, and only one objective function. That makes sense. I mean, if you're trying to optimize different objects, you need to have different objective function. If you're just focusing on one particular goal or one particular target, like in here, it's just focusing on the cost objective function. We're just trying to minimize this guy particularly, then it is just a single objective function, subject to bunch of equality or inequality constraint functions. Okay. This is a mathematical model. And of course, the first thing is how to find actually maximum or minimum value of a function f. But because this is something we learned before from math class. It's just one single variable. Okay. So just the x itself dependent function. How to find it? Right. So what's the mathematical way to find the minimum or maximum value of a given function? What do we do?
Derivative and set it to 0.
Very good. Derivative of it equals to 0. Good. Y is right. So very simple, right? Just EF EX equals to 0. This is the equation we need from where we can find what? Both x value and f value. Does it make sense? Be very careful, okay? From here, you generally speaking, first you find x value, okay? Is the independent variable value. Okay? call it x of m, and but we might be able to find more than one, right? And then from this xm value, you can go ahead to find the what? The corresponding minimum or maximum value for f, the function. Of course, we have multiple. Of course, from this way, what you can find, these are what? Minimum or max value. However, they're called what kind of a minimum or max value? Local, right? It's called local. Local ones. Right? Local ones. It's like a, say you have function x, f of x. It looks like this, right? So let's see. So to this function here, we have one, here one, here one, here one, many, right? If it is fluctuating, we have multiple local minimum or maximum value. Right? Local maximum, local maximum, local maximum, local minimum, minimum, and minimum. Right? That's what we learned from the math class. And how to find the global one. Anyone knows? How to find the global one?
Well, depending on your interval, you have to start first with the interval, make sure that you evaluate the endpoints, because it's possible that the endpoints of that interval is the global, but incorporating the two endpoints, right, and the critical points, that is your possible cases, scenarios to find your maximum and your minimum global value.
But how do you know which is global, which is local?
Well, if it's a maximum, it'd be the largest value of all the critical points, including.
Yep, just as simple like that. Okay, it's actually this question is actually a little bit too easy. How to find the global one? Just compare, right? And compare those local ones from their values. You can tell which is global one, right? Just compare local ones to find the global one, the global one. Okay. Just simple like that. Okay, just simple like that. No tricks. No tricks. And also here, based on this, we can extend this method to the multiple variable function. Find, again, a minimum of f function. This time, it's not x dependent only, but we have up to n independent variables. So how to do this then? So idea is basically we learn first of all the only one independent variable x and how to find the minimum max value of it without constraints, right? Now we go ahead, progress a little bit. So find the minimum or max value of a function with multiple independent variables without constraints still, right? So last we can reach how to find the minimum value or max value for objective function with constraints. Okay, that's the last step. So step by step, we're extending this idea, extending the math. How to do this then? I think it's not difficult, right? This time we should have, as long as you understand what I mean, is a partial derivative as as Noah just mentioned. Okay, this is nothing but partial derivative. Y is partial derivative. Why? Because previously here is just a derivative, right? Derivative. Now we're using partial derivative. Why is that? Is this
multiple variables in the function that can.
That's right. Good, good, very good. Okay. Very good. Okay. Because you have more than one independent variable. So if you're looking for derivative with respect to one of them, you need to use partial derivative. Okay, partial derivative. Okay. All right, delta f, delta x1, delta f, delta x2, yeah, all the way to delta f, delta xn. So you have a bunch of simultaneously happening equations. Okay, simultaneous equation. Okay. Well, speaking out will be much faster, Kevin, like I said before. And from here, if we solve the equations, and then we can end up with what bunch of solutions, right? And this time we're gonna have, say, this is m1, x1, 2, xn. Okay. It's the first group of the solution. Of course, once again, it might have more than one local maximum or minimum value. Therefore, your independent variable solution also might be multiple. Does this make sense? Mx, well, many. Maybe f used. My point is use a different letter as a subscript to differentiate from n. And each one of them corresponding to what? One particular local f minimum value or maximum value. F m1, f m2, and f f. Really? I'm checking the notes here. Well, it's not delta. Well, then I need to do more editing job to my YouTube videos then. Oh my gosh. I need to take a Greek 101. Is there any language course like that offered in SVSU? No one knows? All right. Anyways, here is the math, okay? And you have simultaneous equations, you know, to find multiple solutions of x1 through xn. And correspondingly, you got all of these local minimum or maximum value for f, for the objective function. Okay. Further extending the math to our ultimate goal, which is find the mean value of objective function, one objective function subject to multiple constraint functions. Okay. This is our ultimate goal. So how to do this? And of course, here we are trying to use the equality constraint functions. You might have up to k of them, and all of them are equality. Now how to do this? I think you guys probably have learned this from 302, right? Have you?
We're taking
yet.
it right now. Well, some of us are.
Okay, not yet. That's fine. So how to do this is we need to introduce a so-called Lagrange multiplier, or LM, to involve the objective function and constraint functions. Okay. Somehow you need to mathematically combine them together to become one thing to solve. Now, how to do that? Okay. Is like this. LM, based on the f given here and the g1 through gk given here, LM is equals to very simple, f plus lambda 1 g1 plus lambda 2 g2 plus all the way to lambda k times gk, where lambdas are the introduced new unknowns. Okay, unknowns. Constants. Introduce constants. They're unknowns. So what do you see? Basically, you're simply combining the objective function and constraint function. Very straightforward. Very straightforward in such way. And given assign different weights to different constraint functions, lambda 1 through lambda k. Right, based on which we go ahead. So the rest of the thing are pretty much going back to derivative, right? Partial derivative again. Partial derivative. Yep, I learned. Partial derivative of L, or say LM. I'm just using L, okay? L to represent the Lagrange multiplier, this new function, total function. With respect to x1 equals 0, right? And then this partial derivative with respect to x2 all the way to xn. Then obviously we are not done yet, right? Due to the new introduced lambda 1 through lambda k, what do you need to do? Does it make sense? So lambda 1 through lambda k are new unknowns, okay? New variable pretty much. We have bigger simultaneous equation groups. Okay, so more partial derivative involved. So we can also easily tell above here, how many of them? How many equations? N, right? Below here, how many equations? K, right? Yep. So total is N plus K, number of the equations you need to write. And then what we're gonna have is what are you gonna what are you gonna have? X1, X2, Xn, from the 1, from the 2, from the K, right? This is one set. And you might have multiple set of solution. And each set of solution, once again, determining one particular minimum or maximum local value for function f. They're very straightforward. It's, even though we're writing a lot, but actually the idea is very straightforward. From these guys, you can find the global one by comparing, all right, by comparing them. Okay. So very straightforward, very straightforward. I mean, in terms of the idea. Okay, idea. Any questions before we go through a mathematical problem? Any questions? All right. Let's have an example. Okay, let's have an example. It's a purely mathematical example. Okay, let's see how to use this method. So example 1. Find the minimum distance from origin point to a circle. X minus 8 squared plus y minus 6 squared equals to 25. So you need to do a little bit of recall of the math learned before. So this is circle, right? Circle. What do we know about it? Where's the center point coordinate? Anyone know? Center at
8, 6.
8, 6. Good. With radius of what?
5.
5. Right. This is the circle. What does it look like? If you try to visualize this circle, here we go. It's centered at 8, 6 coordinates with radius of 5. Right? Circle. Many points along the circle, right? And looking for a point. Actually, not looking for that point, but also what? Distance between that point with the origin point. By the way, what does it mean by origin point? Coordinates 0 and 0. the origin point. From this point to this circle, the minimum distance. The minimum distance. So how to apply the Lagrange multiplier to solve this problem? Obviously, we need to first find out f. Second, find out g or g's. Does it make sense? So first of all, object function f is whom? Second, constraint function g is or are whom? Anyone knows who is the objective function in this particular example? Who is it? Or you can go with the constraint function g, whichever you are able to identify first. Any comments?
Would the constraint function be our circle?
Very good. Kevin got the first one. The constraint function is a circle. Very good. And also be very careful. Look back. Okay. Constraint function is what? Equality or inequality with respect to what? 0. Not any other value. Therefore what? You got to move 25 to the left-hand side of equal. Equality constraint. Very good. Does this make sense, first of all? If you incorrectly identify who is f, who is g, then of course, nothing will be right. Constraint function is the circle. And another thing you need to be careful is you need to move the constant to the left-hand side of the equal. To be equality constraint. Next, objective function. Who is it?
Is it just a line with an unknown slope?
Is line with unknown slope? It's a straight line, yes. However,
Is it the formula?
is the what formula? It's too rough.
Square root of x squared plus y squared.
Very good. Very good. Sawyer got it. So first of all, you need to read the problem. The problem is telling you who is the objective function. Okay. Because it's looking for the minimum distance, minimum of the distance. So who is the objective function? Distance is the objective function. Does it make sense? You need to read the problem in this way, so you are able to identify who is the objective function. It's the distance, which is not given here, okay? This is not given here. It's just telling you you're looking for the minimum value of it, okay? Of whom? That is nothing but objective function, right? And distance is between 2 points with 2 different pairs of coordinates, right? So here you need to review one thing. So distance between 2 points who are x1 and y1. Second is x2, y2. is equal to what? Basically, Sawyer was right. X1 minus X2 parenthesis square plus Y1 minus Y2 parenthesis square, right? And then square root of the total thing. Does it make sense? And going back to this particular example, you are seeing the distance here is meaning the distance between 0, 0, this particular point, and another unknown point. Right? Therefore, how to write this objective function? How about unknown point with coordinate x minus 0 plus unknown point y coordinate minus 0 square, and then total square root. Okay? Pretty much square root of x squared plus y squared. This is the objective function, and how we find it. How you understand the given problem. This is the procedure you need to go through. Any questions? Anything unclear yet? All right, nothing like that. Then we can move on. So based on this f and g, obviously we only have one g, right? Only have one g. We don't have any other constraint. One f with one g here. So if you recall, the multiplier here is just simply f plus introduce one lambda. That's enough because we only have one g plus lambda times g. However, you need to understand after that, we need to do the partial derivative, right? However, if your L containing f, and f is something with square root like this, partial derivative going to be very complicated, right? So can we just do a trick like this? How about that? We just assume our objective function as x squared plus y squared. Remove that square root. And why we can do so? Why we can do so? Anyone knows?
Because it's not going to change where the minimum distance is.
Exactly right. It won't change the x and y value, which are the coordinate of the point we are looking for. And it won't change the minimum distance either. Does it make sense? You're looking for that point, making the minimum distance happen, and that point has coordinate x and y. When did minimum distance happen? Okay. X and y remain same. Okay. Remain same. And that's why. Okay. So choosing this easier objective function won't change the minimum value, won't change the coordinate of that point either. That's why we can do this. We really can. Okay. All right. Now it's time to us to find the to develop the LM. So just simply f plus lambda g. 1g, 1 lambda, without any subscripts needed. F is x squared plus y squared. So both f and g are a function of x and y, okay? Two independent variables. Okay. And plus lambda times g. G is here. It's here. This is easy. It's minus 8 squared plus y minus 6 squared minus 25. Right. This is the developed L function. Any questions? All right, we can move on. So from here, we start to find partial derivative, right? How many partial derivatives we need to find? With respect to first independent variable x, with respect to the second independent variable y, and with respect to the introduced unknown lambda, right? N plus k equals to 3, right? Actually, only 3. We need 3. And then the rest of the thing just algebra. Okay, well, not algebra, the derivative. So with respect to x, what do we have? 2x plus what? Derivative of this guy with respect to x equals what? 0. That's right. Plus lambda times bracket. Inside of brackets, what do we have? Derivative of this guy is 2x plus 0 again minus 0 again. So it just equals to 2x plus 2 lambda x. Right? Any questions?
Isn't that we're leaving out the, well, if you were to FOIL out that x minus 8 squared, you'd have a
Good. Very good.
in
Okay.
there. You'd have a minus 16.
Very good. Very good. Okay. Don't make derivative mistake, okay? Because in the past it happens very often. So I'm using the red to emphasize. So derivative of this guy itself with respect to x is equals to 2 times x minus 8. And also you can't forget you have a lambda outside. So pretty much it's 8, and therefore you have, okay. And that equals to 0. And similarly to the y, it is pretty much, say, 0 plus 2y plus lambda times parentheses 0 plus 2y minus 6 minus 0. So what you got is 2y plus 2 lambda y minus 6 equals to 0. And the last one is fairly easy. Yeah, fairly easy. What do you got? That's it. Because x squared and y squared partial derivative with respect to lambda equals 0. This and these two terms are independent of lambda. So you're looking for a derivative with respect to lambda, then 0. The basic concept of derivative. I gave you guys 3 or 4 minutes to try to solve this algebra. Okay. Generally speaking, I won't give time for solving algebra. However, here you need to try it. It's a little bit different. I gave you 3 to 4 minutes to try this algebra out. There's something you can learn actually. Okay, go ahead. All right, so it seems some of you guys have done this algebra. I don't know how you guys did it. Maybe just calculator, but it doesn't matter. Okay, and here, if you're doing it by hands a little bit, then what you see is actually you're seeing lambda times x and lambda times y. Very troublesome. You see this is very, very troublesome. Okay, so how to solve this? If you name the first equation as number 1, name the second equation as number 2, what you need to do is actually this. Equation number 1 can give you negative x equals to lambda x minus 8. Equation number 2 can give you negative y equals to lambda times y minus 6. What you want to do is use number 1, divide by number 2 here. Do a division. Well, this is not number 1, number 2 anymore. This is number 3 and the number 4. 3 divided by 4. What do you got? X over y equals to x minus 8, y minus 6. And further, you're able to derive x equals to 4/3 of y. And then you substitute this into the this equation, into the circle equation, and then you can find the x and y value. Okay. But if you're using calculator, which works perfectly for you, I don't mind. So you got 2 values, and it makes perfect sense. That's a quadratic equation. Okay, quadratic equation. You might have 4 and 12 as x value, and correspondingly 3 and 9 as y value. As I said, you might end up with multiple sets of the equations. That's fine. So this is obviously one set. This is second set, right? Be clear, okay? Be clear in your mind. And the further you're looking for the minimum or maximum value. So obviously, these two, maybe one is the minimum, the other is maximum. It doesn't matter as long as these are local ones. No more. That's all. Okay, and then just do the compare, right? This give you f of what? This give you f what? 3 and 4 give you f of, obviously, what? 25. This f give you 22, 25. Right? The minimum value is 25 for f. Any questions? Are we done here?
You have the point. Now I gotta calculate the distance.
Very good. Very good. Okay, now this is another mistake, very popular. We're not done yet. You just find the minimum value of f. However, your f is not a distance. You remember? So the minimum distance is 5. Minimum distance is 5. And the point making this minimum distance happen along the circle is what? 4, 3 coordinate. So if you try to visualize this problem, what do you have? What do you have is like this, right? So assuming you have the x is the, this is x, this is y. First, you have arranging points with coordinates 0, 0. And the circle is located at the center at 8 and 6. See, this is 8. And then 6. Center point, right? Center point. With radius of 5. 5 is what? This much is 5, right? This much is 5. No, this much is 5. This much is 5. This is a quarter of the circle. Does it make sense? Second quarter. Third quarter. Better look than I thought. Once again, coordinates center 8, 6. So the problem is looking for the minimum distance. Well, obviously, you're looking for the here, right? Which is perpendicular. Okay. So this is the distance you're looking for. And the coordinates of this point making this minimum distance happen is 4, 3. Does it make sense? The coordinates of this point is 4, 3. The distance, or say the length of this red, is 5. Does it make some sense? And then, if this makes sense, then how to explain this set of the solution then? This is what? 12, 9 is making what? How to visualize in the picture here? Anyone realize this set, which is not our solution, but how this set of solution makes sense?
That's the max.
That's the max. Very good. How to find it then? Extending this minimum distance all the way towards the center and cross it, intersecting with center, obviously, reaching the other end of the circle. This point, what is the coordinate? 12, 9, right? And what's the distance? This distance, obviously, is the maximum distance. Maximum distance of what? Minimum 5 plus double radius, right? 15. The 15 square is exactly 225. Makes perfect sense. Okay. All right, here I'm receiving a question here asking how we got here. So from equation 1, you got this and this. Any question regarding equation 3 and 4? Okay, if this is clear, then you use 3 divided by 4. And then left-hand side is x over y. Right-hand side is x minus 8 over y minus 6. And from here, what you want to do is do cross multiplication, right? You x times y minus 6x equals to x times y minus 8y. X times y are canceled. You let negative 6x equals to negative 8y. That's how you got here. Okay.
So how did you know to take 1 and 2 and just divide them? Like just looked at it and kind of guessed that, hey, we should try this?
How did I know to do it?
Yeah.
Because like I said, this is very troublesome. The product between lambda and x and the lambda and y. When I see this product, I was like, no. But once again, if your calculator is so powerful to solve this for you, I don't mind. Kevin said he solved for lambda on the x equation, then plugged it into y equation, then finally into the g equation. Solve the lambda. And yeah, that might work too. That might work.
Whole bunch more algebra to mess up, but I ended up with the same thing. I just got
Okay.
y equals 3/4 x instead of x equals 4/3 y.
Mm-hmm. Yep. Either way, you can do it. Yeah. Either way, you can do it. Any other questions?